Given three non-coplanar vectors A, B and C, we need to check whether the following three vectors are coplanar or not. Okay, let us begin. So here, let's do one thing. Let's name the three vectors. We're going to name the first vector as A vector. The A vector corresponds to 5A vector plus 6B vector plus 7C vector. B vector, that's going to be represented by 7A vector minus 8B vector plus 9C vector. And then we have C vector represented by the vector 3A vector plus 20B vector plus 5C vector. Fine. Now, we will suppose that these three vectors, A vector, B vector and C vector, let's say these three vectors are coplanar, although we need to check, but we are beginning with an assumption there that they are already coplanar. If they are coplanar, then it immediately means that if we pick up any one of the vector, so let's say we pick up A vector, this can be expressed as a linear combination of the other two vectors. That means we take some scalar x, multiply with the second vector and add it to another scalar y times the third vector. So this is how we can check whether if three vectors are coplanar or not. Now, our next task will be to solve for the values of x and y. So we will substitute A vector with its respective vector. So we have 5A vector plus 6B vector plus 7C vector. This is going to be equals to x times B vector. So we'll multiply x with B vector to get 7x A vector minus 8x B vector plus 9x C vector. So this gets added to y times C vector. So we have 3y times A vector plus 20y times B vector plus 5y times C vector. Now we can combine all the like terms on the right hand side. So we combine 7x A vector with 3y A vector to get 7x plus 3y multiplied to A vector. Then we're going to combine the terms containing B vector. We have negative 8x added to 20y whole multiplied to B vector. And then finally we're going to combine the terms containing C vector. So we have 9x added to 5 times y whole multiplied to C vector. And on the right hand side, left hand side, we already have 5A vector plus 6B vector plus 7C vector. Now we're going to compare both sides. Comparing both sides is going to give us three equations. So we have 7x plus 3y. This is going to be equals to 5. Then the next equation, we have negative 8x plus 20y. This is going to be equals to 6. And then we have 9x plus 5y. This is going to be equals to 7. So here we have three equations. Now what we'll do, we'll pick up any two equations at a time and then solve for the values of x and y and use the values of x and y and substitute in the third equation. If it satisfies the third equation, then we can immediately say that the vectors A, B and C are coplanar. Okay, so let's say we can number this as equation number 1. Now here we can further reduce this. If we divide each terms by 2, we're going to get negative 4x plus 10y equals to 3. We're going to label this as equation number 2. And then we have equation number 3. Now, we'll try to solve, let's say, equation number 1 and 3. We're going to get x equals to 1/2 and y also gives us the value 1/2. Now, that I'm leaving as an exercise for you to try out. It's a very simple equation. Now, what we'll do, we'll use this values of x and y and substitute in equation number 2. Now, 2 is going to give us, so we have negative 4 multiplied to 1/2 added to 10 multiplied to 1/2. And we need to show that this is equals to 3. So negative 4 divided by 2, so that corresponds to negative 2. Added to 10 divided by 2, so that's 5. 5 equals to positive 3. So negative 2 plus 5, that's simply 3. So we have 3 equals to 3. Now this is satisfying our second equation. That means solving 1 and 2, whatever x we obtain, which is half, and both half for x and y, that is satisfying the second equation. That means actually our assumption was true. So that means A vector, B vector and C vector are indeed coplanar. Let's write it down. Hence, the vectors A, B, and C, these three vectors are coplanar, meaning they lie on the same plane. Hence proved.